Okay, so in the last lesson you got a chance to review mean, median, and mode, and you got to extend the concept of mean to looking at group data and weighted data. What we're going to do today is we're going to do a couple more of different types of examples of finding mean, median, and mode, and then talk a little bit more about, now we know three types of central tendency, three different measures, looking at which one is better than the other for certain situations. We'll talk a little bit about how to deal with outliers. But first off, here's a bit of a warm-up that sort of stems from last night's homework. So we have a collection of 125 pennies, and what they've done is they've grouped them by the decade they were produced. So looking at this collection of 125 pennies, we want to find the mean, median, and modal interval of the date of their pennies. So what I'd like you to do is try this on your own first as a bit of a warm-up, and when you have all your answers done, push play again, and we'll go through the answers together. Okay, so you can take a look and check your answers there. So for the mean, I got 1986.34. Now, before we get into how I got that, remember that this is grouped data here. So again, we don't know what the original dates are in all these pennies. So what we have to do to each value that's in each interval is assign it the value of the midpoint. So for example, halfway between 1990 and 1999 is 1994.5. Now, unfortunately, it's one of these things that's actually an example of a meaningless number, because we know that the dates in the pennies are not in 0.5s, they're just simply years. But we're simply going to use that value of 1994.5 as an assigned value to help us calculate the mean. Similarly, we get midpoints for the other intervals of 1984.5 and so on and so forth. So remember now that for example, in the first interval here, all 56 of these values are going to be assigned 1994.5. So when I calculate my mean, I take 1994.5 and multiply it by 56. Do the same thing for all the other intervals. So I multiply the midpoint 1984.5 by the frequency, which is 42, and so on and so forth. Add them all up. I divide them by a total number of values I have, so in this case it's 125 pennies. Okay, and I wind up getting 1986.34, and that's going to be the average year. Now, again, 1986.34 is kind of a meaningless number here, but we can just say around this is be approximately 1986 as the average year or average date on her pennies. Okay, so that's for the mean. The next one is for the median. There's often some confusion when you have group data as to what you give for the median. Do you actually give the midpoint value? Do you give the interval that the median lies within? And it usually depends on the wording of what's being asked. So if this had asked for the median interval, then you could have mentioned that the interval at which median falls in between is 1980 and 1989. However, this asks for the specific median. So as it turns out, the median value is within this interval right here, so we're actually going to assign it 1984.5. Now again, as we know, 1984.5 is kind of a meaningless value in this context, but it is the value that we get for the median. Now, how did I get that? If it's a small amount of data, it's very, very easy to sort of put the data in order and count out to see the middle one. There's 125 values here, though, so it's a little bit trickier to find the middle value. So a little trick rule of thumb that you help find the middle value is you take our n, or in this case our 125 pennies, our total number. Okay, if we add 1 to that, and then divide by 2, what that gives us is 63, right? 125 plus 1 is 126, divided by 2 is 63. What that tells me is now the 63rd data value is going to be the median. Okay, so the first 56 are here, so the 63rd would follow in this interval right here, which is why my interval is going to be 1980, 1989, or 1984.5 will be the value I assign for the median right there. Okay, so again, nice little trick to help you find the middle value when you have large groups of data. Okay, and last but not least, the modal interval. Again, ask for the modal interval, so I give the whole interval of 1990, 1999. If it asked for simply the mode, I would have assigned it the meaningless value of 1994.5. Okay, so that's hopefully it was a nice little warm-up, and hopefully that might clear up some of the issues in last night's homework as well. Okay, let's look at another type of problem here. So here we have a student who has a mark of 74 at the end of the term, and we know the term works for 70% of our final grade. And we want to know what mark they need on the summative exam, which is, just to be clear here, the summative exam total is going to be worth 30%. And they want to get a final mark of 70 in the course. Now this is the type of situation that students run into often, right? They know their mark towards the end of the term. They need to know how well they need to do on the summative, or the final 30% of the course to achieve a certain goal. Okay? So this is really just an example of using weighted means. So when you're dealing with weighted means, we know from our formula sheet, or from looking at yesterday's lesson, that if we want to find our mean, pardon me here, make some space. If we want to find our mean, it's going to be simply the sum of each weighting times the value associated with that weighting divided by the sum of the weightings. Okay, so in this particular case, again, this notation can be a little bit confusing because we're just getting used to it now, but all this means is that we take every possible value we have, okay, multiply it by its weighting, then divide by the sum of the weightings. So we know we want the final mark in this case to be 70. So we want the final average to be 70. We're going to put that into here. Okay, so this is what makes it different from the problems we were looking at yesterday. Yesterday we were calculating the weighted average. Here we know we want the final weighted average to be. We need to figure out what that unknown value in this part of the equation is going to be to help us achieve that mark of 70. So again, what we know here is that we have a mark of 74 that's weighted for 70%. Okay, so what we're going to do is we're going to take that weighting of 70%, I'm going to turn to a decimal, so I get 0.70 times that mark of 74. So again, we're weighting down that mark of 74 for the term. Okay, and we're going to have to add that to the summative exam mark. So we know it's worth 30%, so I'm going to weight that at 0.30, or just 0.3. And we don't know what that summative exam mark is going to be. That's right, what we're trying to figure out. We want to know what mark she needs on the summative of her exam to get that final mark. So let's just call that our unknown. Let's just call that, I don't know, let's call it M for mark. Okay, well then what we divide it by is the sum of all the weightings. So our weightings here was 70% for term, 30% for final, so 100% total. So as a decimal, it's just going to be 1. Okay, so what I actually have now is an equation that's set up. Okay, and my unknown is over here on this side of the equation, and I have to solve for M. Again, that's going to be the mark that she needs to get the final that's the mark she needs on the summative exam to get a final mark of 70. So let's solve for this. So this dividing by 1 doesn't really change anything right here, so I'm just going to leave it. So I'm going to have 70. Okay, 0.7 times 74 gives me 51.8. And I have 0.30 m. Okay, so using some algebra here, I'm going to subtract 51.8 from both sides. So I get 18.2 is equal to 0.3 m. Then dividing by 0.3 gives me a mark of 60.7 approximately, again to one decimal place. So what that tells me is that as long as she achieves at least a 60.7 over her summative exam, the final 30% of the course, she'll achieve a 70 in the course. Okay, and again, this types of problems that you've seen before, but it all is just an example of weighted average. Okay, what I'd like you to do now is take a look at part B. Just try it on your own. We want to achieve a mark of 83. I want you to try and calculate what mark they need. When you're finished, push play and we'll go through the answer together. Okay, so you can check your answer there. This one's almost identical to the one in part A, except now we have a different desired final mark. Now she wants to get an 83. However, this time when you solve for it, you wind up getting a mark of 104. It means you have to get 104% or summative of an exam to get this final mark. Now, assuming the teacher does not give out bonus marks, this mark would actually be impossible. So it would actually be not possible to achieve an 83 in the final course for this particular student. Okay, so let's move on. So now a different type of weighted average question here. So we know their first 4 test marks, and we know there's going to be one more test before midterm report cards, and they want the report card mark to be 80%. We want to figure out what mark they need next. So assuming all the tests are weighted equally, what do they need to get? So I'd like you to try and think about this one on your own first. Try and set it up and solve it, and when you get an answer, push play, and we'll go through it together. Okay, so the big help in this situation is that all the tests are weighted equally, right? So we don't have to worry about weighting them down by, let's not say like the first ones were 30% or 20% for the next one, so on and so forth. They're all tests are weighted equally. So we can go back to our formula for the mean here, and we're knowing that simply that the mean is equal to sum of all your values divided by the number of values you have. So with the next test included, there's going to be 5 tests in total, so n is equal to 5. We know the first 4, so it's going to be 75, 81, 83, and 69. It's only the fifth one we don't know, so I just called that one a variable t. Okay. Now in this case, again, we know what the final report card mark would like to be, or we know what the final report card mark they want is going to be 80%. So if you throw that in there for the mean, we can actually then solve for t. So going back to your algebra here, adding these four values together, we get 308. So 80 is equal to 308 plus whatever that fifth test is divided by 5. What we then do with both sides of the equation here is we multiply both sides by 5. So I get 400 on the left side of the equation, 308 plus t on the right side. So a quick little solve there tells me that they would need 92 on their next test to get a report card mark of 80. Okay, so a couple of things I just wanted to discuss with you guys. So again, we have three measures of central tendency we've looked at: mean, median, and mode. So we want to talk about which one is best. Now, before we go any further here, I should say that every situation is going to be a little bit different from the other, right? So you need to use some judgment here and just make sure you're not intentionally going out to mislead people when you report on statistics. So the thing to really look out for is the idea of an outlier. So what is an outlier? Okay, well, an outlier, and here's an example one here, is a data value that doesn't seem to fit in with the rest of the data that you have. So let's just say you have all these points drawn here. You have a line of best fit, and you see right here this point doesn't seem to fit with the others. And that can happen in any kind of data collection all the time. I mean, it could be that you look at a set of class marks, right? And most people have marks in the 60s and 70s, but you've got one person who has a mark of a 95 or 96, and one person who has a mark in like 10 or 12%. So these two marks are so far beyond how everybody else is doing in the course that they really don't fit in with the others. So if there is an outlier, it can heavily affect the mean. Okay, I mean, if you picture a class where most people have marks in the 70s or 80s, and there's one or two people in the class who, let's say, haven't shown up very often, they have a mark about 20%, if you include those 20%ers inside the mean, well, the mean's going to make the class look like it's doing a lot worse than it actually is. Okay, so they are part of the class, so you do want to include them, but the mean may not be the best way of representing how the class is doing. So in that case, you want to use a median to report the class average. And in fact, that's what they do on report cards in Ontario as well, right? You'll notice that next to your mark on the report card, they put the course median, not the course average. Reason being that the median is going to be a better measure of how the class is doing. You make a quick comparison with yourself. If your mark's above the median, you're in the top half of the class. If your mark is below the median, you're in the bottom half of the class. So it makes it a little bit simpler that way. Okay. Sometimes when you're doing a report, it's the frequency that's most important. So again, which answer appears most often. So in that case, you want to report on the mode. But however, if you need to do further analysis with the results, mean is often best. So again, every situation is different, and you just want to make sure you're not going out to mislead people. So again, outliers. The one big one is that outliers tend to skew the mean, so you want to go with the median. Okay, and the last thing I'll talk about here is when you have outliers, when you have these pieces of the data that don't appear to fit, how do you deal with it? Can you just ignore them? Can you remove them? Or do you have to include them? And again, it depends on the situation. So what you need to look at is, if you know how the data is collected, you need to see if you have a strong argument as to why the outlier should be removed. So let's say there's a clear measurement error. Let's say somebody reported their height in meters versus centimeters. That number that they gave is a lot lower, right? So you need to be careful about that. Let's say they misunderstood the survey question and gave an answer that was so far to left field it doesn't seem to fit. Like, if you know that because you were part of the data collection process, then you can make an argument why that outlier should not be included, and then complete the analysis without that value. Okay, but if you don't know, and often you don't know how the data was collected when you're looking at it, you can't just ignore a point because you don't like how it fits with the rest of your data. That would be misleading to whoever is reading your report, right? So if you're ever in doubt, the best thing to do is to do the analysis twice. You do it once with the outlier and once again without the outlier. Okay, and that way you can report both results and let the reader come to their own conclusion as to whether or not the outlier was valid or not. Okay, and that's why you're not misleading anybody. Okay, so again, those are some general rules of thumb to how to deal with outliers. And you'll get an opportunity when you do some data analysis in this course and see some types of sample data sets. Okay, so that's it. That's all for this lesson. Homework's up on the website. Good luck, and let me know if you have any questions. Thanks a lot.